Hello everyone, welcome to Simplilearn's YouTube channel. Today we will be discussing about the longest common subsequence problem. But before we begin, let me tell you guys that we have daily updates on multiple technologies. So if you are a tech geek in a continuous hunt for latest technological advancements, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without any further ado, let's get started with the agenda for today's discussion. We'll start this discussion by understanding what longest common subsequence problem is. Following that, we'll go over the longest common subsequence implementation using recursion. And finally, we'll cover the solution for longest common subsequence problem using dynamic programming paradigm. I hope I have made myself clear with the agenda. So let's get started with our first topic, that is understanding what the longest common subsequence problem is. The term longest common subsequence clearly directs us towards some sort of relation between two sequences. A sequence is nothing but a series of elements that occurs in same order but are not necessarily contiguous. From this definition, we can say that the longest common subsequence will be the term that both given strings will contain. To understand it more clearly, let's have a look at an example. In this example, I have taken two strings. There is nothing like substring here, right? If you have studied the KMP algorithm, you'll remember the problem as string and substring. In that problem, we had to find the substring inside a given string. But this scenario is totally different from that. We'll be dealing with two different strings here. Here you can clearly see that string 1 is larger and string 2 is relatively smaller. Now, for these two strings, possible common subsequences are as shown on the screen. And from this, you can clearly say that the longest common subsequence will be CDE. Moving forward, let's dive further into this LCS problem to understand the logic behind it. The problem statement for the LCS states that given two strings, find the length of common subsequences present in both the strings. That means in this problem, we'll be given two different strings with length m and n respectively. And from these two strings, we'll have to find the longest common subsequence with length k. Let's consider these two strings present on our screens. We'll try to find out the LCS for both of these strings here. We'll try to map patterns present in string 2 to string 1. Now let's pick the first character in string 2, that is Z. Now we will match this character to the character present in string 1, and the first character is X. So we'll map it with X, but Z and X do not match. Hence, we'll move towards the next character. Next character is Y, and Z and Y also does not match. Hence, we'll move to the third character, that is Z. Here, we have found the match. So what we'll do is we'll include Z into our longest common subsequence. The next character in our sequence is A, and we have A in string 1 as well. Hence, we'll include A in our longest common subsequence. The next character in string 2 is D, and we have found match for D in string 1 as well. Hence, we'll include it in our longest common subsequence. The final character in string 2 is F, and we have found F in string 1 as well. Hence, we'll also include it in our longest common subsequence. Finally, the longest common subsequence for string 1 and string 2 will be ZADF. Moving forward, let's discuss one more problem to understand LCS clearly. Here you can see that Z is present in both the strings. Thus, we'll include it in our LCS string. The next character is Y. It is also present in string 1, but the rule of LCS says that the sequence of character should not be changed, and here the mapping line of Z and Y are intersecting. So we'll discard character Y here, and we'll pick the next character in string 2. That character is D, and D is not intersecting with any other character, hence we'll add it to our LCS string. Now, the next character B is also there in string 1, but we cannot insert it in our LCS string as it intersects with the mapping line of character D. Thus, we'll discard this character. The next character f can be added to our LCS string as it does not intersect with any other mapping line. So, the first LCS sequence will be ZDF. And due to multiple intersections, there is possibility of having another sequence that can be larger in length than the previous sequence. For this sequence, we'll begin from the second character of string 2, that is y. And y is present in string 1. Thus, we can add it to the LCS. Next, we can add d to our LCS sequence. After this, we have b, but b cannot be inserted into LCS as it is intersecting with d. Hence, we'll discard it. And finally, we'll include f into our LCS sequence. In this problem, both the sequences have the same length. Hence, both of these sequences will be considered as longest common subsequences. I hope that you guys have understood the logic behind finding the longest common subsequence, cause we have a challenge for you guys to assess your understanding of the LCS. For these given sequences, you are supposed to find out the longest common subsequence. The options for this problem are BABC, BACE, and BCE. You all can drop your answers in the comment box below. Let's see how many of us can get this right. Now moving forward, we'll build a solution for LCS using recursion. So let's visit the code editor and develop the C program for longest common subsequence. The two strings for which we are going to find LCS are xy and xpyq. Let's create a function to get started with LCS implementation. I'm going to name this function as int LCS, and inside this function we'll pass the references of two character arrays. The first will be char star a comma char star b. The next arguments will be the lengths of these character arrays int x and int y. Now we'll move to the function body of LCS. The first condition we'll evaluate is if the character array are empty or not. Because if character arrays are empty, then definitely there won't be any sequence to find out. So when we reach x equal to 0 and y is equal to 0, we'll return 0. For that, we'll write a condition if x equal to 0 or y equal to 0, then return 0. Now, the next condition, when both x and y won't be 0, we'll check if the last character of both character arrays match or not. For that, we'll write another if condition. If a x minus 1 equal to b x minus 1, then we will return 1 plus LCS a comma b comma x minus 1 comma y minus 1. Once this condition gets fulfilled, we'll return 1 plus recursive call to LCS function with inputs decrease in size by 1, that is x minus 1 and y minus 1. Now, if both the previous conditions fail, then what we'll do is we'll go into this else part, and inside this else part, we will return max of LCS a comma b comma x comma y minus 1 or LCS a comma b comma x minus 1 comma y. We are missing semicolon here. Okay, and dot here. So We'll change it. Now, this statement will get executed when there is no character match. If characters don't match, we'll move either way, one character in first string A or one character in second string B, and check whichever gives maximum, and we'll take that into consideration. Most of the time, this condition will get satisfied. To find out the maximum, we'll have to create a manual maximum function. So for that, we'll create a new function, that is int max, and we'll pass arguments int m, int n. Now inside this function, we'll write a ternary condition, that is return m greater than n question mark m colon n semicolon. So this will return the maximum value between m or n. With this, we have successfully completed the LCS function. So moving forward, let's work on our driver function. In driver function, what we'll do is we'll create two character arrays at first. So for that, let's enter into this main function and we'll create character array A, and inside A we'll pass X and Y. Inside character array B, we'll pass X, P, Y, Q. Okay. And we'll store the lengths of these character arrays into X and Y. For int X is equal to strlen A, and for int Y strlen B. We'll add semicolons here. And finally, we'll make call to our LCS function using the printf statement. The printf statement that we'll write is length of LCS is modulus D, comma LCS A, comma B, comma X, comma Y, semicolon. And finally, we'll add return 0. I hope our code is bug free now. So let's run it and check if it is bug free. That's fine. Here we are getting error, but it is not exactly an error. We have implicitly declared function max here. So that's why we are getting this flag problem, but we are actually getting output as well. So the output that we are getting is 2 here. And if you check both the strings, then you can find out that character array A is implemented inside character array B, and the length of common sequence is 2 here. So with this, we can say that our recursive implementation of LCS is successful. Now moving forward, we'll visit PowerPoint to understand why recursion is not an ideal approach to solve this problem. To understand the complexities associated with longest common subsequence problem implementation using recursion, we'll formulate a recursive tree by going through the steps of a program that we have created previously. So let's do that here. As you can see in this LCS function, the first step we perform is checking if both the strings are empty. If they are not empty, then we check if the last character of both strings matches or not. Thus, the first call to the LCS function will check for the match of last two characters. If characters don't match, which is true in this scenario, we move either one character in string A or in second string B, and we'll choose whichever produces maximum value. So if we reduce B by 1 and keep the A same, then we have a character Y in both the strings. Whereas if we keep b the same and reduce a by 1, then we have x and q which don't match with each other. First, we'll evaluate the left side of our recursion tree. And here we have a character match. Thus, we'll enter if condition where characters do match, that is this condition. And it says that return 1 plus both the character arrays with size reduced by 1. And by doing that, we get two different characters x and p here. Now, as these characters do not match, we'll move position by 1 in both the strings. By doing that, we get these results. And here, if you observe, the left child has a character match. Thus, we'll add 1 and reduce the size of both character arrays by 1. And with this step, we reach the end of our strings. Now let's work on the right side of our recursion tree. In this case, we have distinct characters. Thus, we'll move by 1 in both the character arrays, and the resultant child nodes don't have characters that match. Furthermore, the right child reaches the null index. Hence, now we will just expand the left child. In addition to that, we can move positions only in character array B as we have reached the end of character array A. For this move, we do not have any match, so we'll reduce the position of B by 1 again. And here we get a match and also reach the end of both character arrays. Now, the next step will be for evaluating LCS length by backtracking our recursive tree. First, we'll consider the left side. So let's begin from the bottom of left side. At the bottommost child, we have some value equal to 0. For the next step, we'll have some value 1 as we will add 1 here. For the next step as well, we'll have to add 1 to our sum value. Thus, the sum value will become 2 here. And the overall sum for the left side of recursive tree will result into 2. Whereas for right side, the sum will become 1 as there is only one match. Now, the side which has maximum sum value will be returned as a result of this LCS program, which will be 2 in this case. The complexity for this recursive LCS program will be 2 to the power n. Now, for these two strings which have small length, you can see that the complexity will be equal to 2 to the power n, where n belongs to the depth of binary tree. That is huge complexity. If you look at the complexity graph, you'll get parabolic graph, which will increase continuously or exponentially. However, this problem can be resolved by using dynamic programming paradigm. Moving further, we'll try to analyze how dynamic programming can reduce the computational complexity of LCS problem. Here, we'll try to solve LCS problem using the tabulation method in order to understand how tabulation can reduce space complexity by making fewer computations. The LCS function for tabulation will be iterative. Hence, we'll understand the computation with the help of tabular representation. The columns will represent character array B and rows will represent character array A. Furthermore, we have added the null values to the table. Hence, initially we'll set the field values for null row and columns as 0. Now here, we'll move through the row of character X. For the first iteration, we hit the match. Hence, we'll add 1 to the diagonal element. So, 0 plus 1 will become 1. For the next iteration, we get X and P which do not match. Hence, we'll continue with 1. Next, we have X and Y which also do not match. Hence, we'll continue with 1. Remember guys, the highest value between these two fields will be picked every time. For the next move, the value 1 will continue. Now moving forward, we'll move towards the Y row. Here, for both X and P, the values will remain 1 as we don't have the character match. But for the next field, we'll have a match. Hence, we'll add 1 to the diagonal field. The value for this particular field will become 2 now. For the last field, the value 2 will get continued as it is the highest field than another comparative field. And you can see that we have found the accurate result here, which is 2. I hope this tabulation logic is clear to all of you, cause moving forward, we'll develop a C program for the same. Now, in order to get started with this tabulation function, we have created int LCS function with few arguments. These arguments are similar to the recursion. In this tabulation LCS function, we'll first create the 2D matrix for performing the computation. The statement that will help to do that is int L x plus 1 x plus 1 and y plus 1. So this will create a 2D matrix of size x and y. We'll also initialize few variables for using them inside looping process. So I'll create two variables int I and j. Next, we'll create a nested loops for traversing through both arrays at the same time and updating the computational table. For that, we'll create for loop, and inside this for loop, we'll begin from I is equal to 0 to I is greater than equal to x, and we'll increment the I. And inside this for, we'll create another for loop, and we'll begin this with j is equal to 0 to j less than or equal to y, and j plus plus. After that, we'll write the first condition to set null values for the null row and column fields. So the statement that we'll write is if I is equal to 0 or j is equal to 0, then set L I j equal to 0. If this condition fails, then we'll check if the last character match with one another. If they match, then we will return 1 plus both array fields reduced by position 1. For that, we'll write condition else if a I minus 1 equal to b j minus 1, and inside this else if condition we will set L I j is equal to L I minus 1 j minus 1 plus 1. And if this condition fails, then we'll enter into else loop and we'll pick Lij as maximum of L I minus large L, and here as well it should be large L I minus 1 j comma L I j minus 1, and we'll get out of these for loops and we'll return the output, that is L x and y. I hope this should be fine now. So let's run our code and check if there is something wrong. We'll save this as lcs underscore dp. Okay, so we are getting 3 problems here. Okay, so I have inserted O here instead of 0. And there is one more mistake. So I have called function max as max here and have named it as maximum here. So we'll have to change this to maximum. I think this should be fine now. So let's run our code again. Okay, we'll have to save this. So we'll paste Control S and we'll rerun it. Yeah, so we are getting our output here. The length of longest common subsequence is 2. So if you observe here, the output that we have got using dynamic programming is in 5.58 seconds. And the time that was taken for LCS recursion was around 8 seconds. So you can see that the complexity has been reduced, the time complexity and space complexity as well. So that is why the dynamic programming is better approach than recursive programming paradigm. I hope the longest common subsequence problem implementation using dynamic programming is clear to all of you out there. So with this, we came to the end of this video. I hope this video on longest common subsequence was informative. If you have any queries regarding this topic, then let us know about it in comment section below and we'll get back to you. Thank you so much for being here and do watch out for more videos from us. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.